One important property of orthogonal matrices is that orthogonal matrices preserve lengths and angles. So we want to show that the length of AX is equal to the length of X. Now, because both of these lengths are greater than or equal to 0, this is equivalent to showing that the length of AX squared is equal to the length of X squared. Okay, so that's the first thing we want to show in this example. And the second thing is that if theta is the angle between X and Y, then theta is the angle between AX and AY. Right, so the orthogonal matrix will preserve the length and it'll preserve the angle. And so this is important when we think about the rotation matrix being an orthogonal matrix. We want to be able to rotate vectors and maintain the same length of the vector and maintain the same angles between the vectors before and after we rotate them. So let's look at the first property, the length of AX squared. Well, this is going to be the dot product of AX with itself. So we've got AX, the transpose, times AX. And using our properties of transposes, this is going to be X transpose, A transpose, times A times X. And of course, this multiplication, we can't rearrange the order, but we can change where our brackets go. So this is X transpose, A transpose A times X. Now, A is an orthogonal matrix. Because it's an orthogonal matrix, we know that A transpose A is equal to the identity matrix. That's the important property that orthogonal matrices have. So this is X transpose times the identity matrix times X. And of course, that means it's X transpose times X. But X transpose times X is the dot product of X with itself, or the norm of X squared. So the first property is indeed satisfied, right? Taking a vector X, multiplying it by an orthogonal matrix does not change the length. How about the angle? Well, let's look at the angle cosine theta between AX and AY. So this is the dot product, well, this is the inner product of AX with AY times length of AX, length of AY. Okay. Well, from our first property, we know that the length of AX is equal to the length of X. So this is going to be the length of X, and this will be the length of Y on the bottom. On the top, we've got this inner product. And so we can figure out our dot product. So this is AX dotted with AY. This is going to be the length of X from property 1, and length of y for property 1. So this dot product here is going to be AX transpose times AY using our properties of transposes. We've got X transpose A transpose AY. We know that since this is an orthogonal matrix, A transpose times A is the identity. So we've got X transpose times Y over length of X, length of Y, and X transpose times Y is the inner product of X and Y. So this formula at the end is the angle between X and Y. The formula that we started with was the angle between AX and AY. And obviously what we've shown here is that the two things are indeed equal. So orthogonal matrices have this important property that they preserve lengths and they preserve angles.